All right, so let's get started. My name is Min B, and I've been working with AWS for about 2 years now. I work with AWS Mobile, so all your mobile SDKs with iOS, Android, Xamarin, etc. of that nature. Today we'll be looking at how to develop well-architected Android apps with AWS. So a little agenda, we'll go over what our app requirements are, then look a little bit at the architecture, both local and on the cloud. And then we'll look at AWS Amplify CLI, which is what we'll be using as our tool chain to provision all of these backend resources. And then we'll go into Android architecture components and how that fits into the AWS ecosphere. For the functionality, we'll be looking at sign-in. You're going to sign in your users, allow them to have usernames, accounts, etc. Then you're going to access the data, and then further engage your users by collecting analytics about what they're clicking, what they're interested in, etc. Things like that. And what I mean is we're going to be building a social news app. We're going to have a news article feed, so basically a list view with all of the news articles that we want to look at. We'll be able to display this feed, comment on the news articles. So once you click on one of these news articles, it'll pop up with a more detailed view, and then you can start adding comments if you're signed in. This is where authentication comes in. Once you're authenticated, you can start giving your users elevated permissions. In our case, they have the ability to comment on the articles. And once you have this great and wonderful app up and running, you'll start to wonder what to tweak and what to add to it. So you need to start adding analytics. For us, we'll be looking at when users sign in, when users sign out, and overall which news articles they're interested in by collecting which news articles they're actually clicking on. So other app requirements we have are basically, with business-driven goals, it's always we need to display X and make changes for Y, but there's an implicit requirement that is common for everyone that's building an app. The app needs to be responsive overall, and we need to achieve that through a few ways. One is cache. Cache not only gives you speed, since disk is order of magnitude faster than network, it also gives you the ability for your app to operate offline. Another is we want to use efficient network. So we only want to download the amount of information that we need to download. So for example, the list view of the news article, you might only want to download the title and the synopsis of the news article, but once you actually click into the news article, you want the full content, all of the comments on it, and just that would take more bandwidth, but you want to delay that until your users are actually interested in that article. And then last is we have data-driven UI updates, so that our UI isn't fully aware of what's underneath. Rather, whenever the data changes, we want an event to go up to the view and say, here, you should update your text view with the latest and greatest text. We'll be doing that through live data and room. So this is a little bit of the local architecture that we'll be using, basically the application. We'll start with the activity up here. The activity will be our view. It'll talk to the view model, which holds a bunch of live data references. These live data references are being given by the repository. The repository layer will be communicating with both the database layer on the left with the model and room, and on the right, AWS and the AWS mobile SDKs for fetching this information from the cloud. How the repository will be determining that by potentially, is there something in the cache? If not, go to the cloud. And even if there is something in the cache, maybe it's 3 or 4 days old. So you'll want to show the maybe more stale data, maybe make a marker on it, but at the same time send off an asynchronous call to refresh that data. And once that's available, show that to the users with effortless updating the database, and then that database will automatically go to the view and say, we have fresher data for you to see. So that's the local architecture. For the cloud architecture, we're going to be using a few services. The first will be Amazon Cognito. This will be what we're using to sign in our users. Not only sign in our users, but also give them permissions to access the AWS resources that you might want them to access. Say, for instance, being able to view the article. Next is AWS SAP Inc. So that'll be our API layer that's serving all the data that we'll be using today. We can use multiple data sources. For our example today, we'll be using Amazon DynamoDB. And the third service that we'll be using is Amazon Pinpoint. That's what we'll be using to collect analytics about our users. Once we collect analytics, the other half of Amazon Pinpoint is to be able to engage them. And what I mean is you can send push notifications, you can send email notifications, things like that once you've gained a little understanding of what your user might be interested in. For the news article, maybe the user is interested in pineapples, and you've gotten a new news article that says there's a new strain of pineapple. So you might want to send them a push notification and tell them about that, and maybe they'll click on that news article. So how are we going to do all this? Well, the developer will be using the AWS Amplify CLI. This will be what we'll be using to provision all of these cloud resources. But first, let's take a look at AWS SAP Inc. How we're going to communicate with that and what overall the query language is. AWS SAP Inc. will be using GraphQL, and right off the bat, one of the things that you get is a dynamic response shape. And how that works is, again, the list view versus detailed view. So the same API, you can ask for certain fields. So with the query language, you have this overall line 1 query get news. On line 2, you have the actual method called get news. You're looking at for an ID of 1, 2, 3. And then on line 3 and 4, you're asking for the ID and title back. ID is a good practice because you want to echo what the arguments you want, and title, basically this will be your list view. But the same API, once you're looking at a detailed view, you want to maybe use a little bit more bandwidth just so that users have information to look at. The same API, you can ask for so many more fields on lines 5 through 24. On the right side, you can see you can ask for the image that's tied to the news article. You can ask for the synopsis, publish date, and all the comments attached to that. So that's how you would use the query language with AWS SAP Inc. So what is AWS SAP Inc? It is a managed serverless GraphQL service. So we manage all the queries, mutations, subscriptions that you would be using to get this data, and we'll dive into that a little more later on. You can connect to data sources in your account, multiple data sources if you wish. These can range from Amazon DynamoDB, which we'll be using today. We've also launched support for Amazon Aurora. Then another feature would be that we're offering data sync, real-time and offline capabilities on your data source or API. So we have subscriptions. So this is another way that you can reduce the network bandwidth. Subscriptions allow you to tell the service that you're interested in certain events. For us, maybe a new comment has come in. So if the user is looking at an article, they can open up a WebSocket to the service, and the service will say, okay, this client is interested in new comments on a certain news article. And then once those comments come in, the service will make that determination and push down that delta. So the delta will be relatively small, and you can show that data automatically in your UI. Multiple other things is that you can build GraphQL facades for any AWS service. So this is basically just, you can front any service. If you're using a service in a particular way, that might take 5 operations, but you're using it consistently with 5 operations, you can make a AWS SAP Inc. API for that specifically, and that way it's a facade that one API call will in turn in the back end turn into 5 API calls. The next is conflict detection. So with all of the data sets that we're sending up, if you choose to have a version, then the service will take into account that version. If you have multiple actors acting on the same data at the same time. So for instance, if there are 2 editors looking at the news article, editor 1 makes a change on version 1. Editor 2 is also looking at it at the same time and makes a change on version 1. Well, editor 1 has already pushed up version 2. Editor 2 is saying, I want to make a change on version 1. The service says, okay, you're out of date. It comes back with both of the informations and tells editor 2 that there's a conflict with your data. Here's the latest version and here's your version. Figure out what's changed, and you can tell me the version 3 of the article instead. Of course, we support The next is enterprise security features. We support a myriad of ways to authenticate your calls. One is AWS Identity Access Management. Another is Amazon Cognito. This is through user pools. If your user is signed in, then they can make calls to your service. We also support OIDC, so you can bring your own OIDC as long as they adhere to the protocol. And of course, if you're doing testing or just local experimentation, we also support API keys. So this is the simplest of all the authentication modes. It's basically one string parameter that gets sent with your API calls. And this is mainly for testing purposes when you're not too concerned about security at that time. So this is AWS AppSync. There's a few other things that we'll look at is the clients will receive the data they ask for, nothing more, nothing less. This is alluding to the first article where list views will only ask for the title, the detailed views will ask for comments, etc. You can actually aggregate many resources from many data sources. This is seen when you actually say get news article. It returns you a news article with the comments, but in reality, there is a news article table and a comments article table. AWS AppSync will be going to both of these tables, aggregating that information, and then sending it to you back in one response. Then a feature of GraphQL is that the self-documenting APIs with introspection, if you make a code comment in the GraphQL schema, then that automatically shows up as documentation. We have multiple support on React Native, Android, iOS, Web, and JS. These are through some Apollo GraphQL clients that we've added some custom code on top of to support all of our use cases. We support data persistence across application restarts. Most of our clients, I think all of our clients have an internal caching mechanism. So if you don't want to deal with cache yourselves, you can rely on the internal caching mechanism to save the data and save you network calls whenever there is caching available. Another is write-through mutations with optimistic UI. So if, for instance, your app is offline and you're making an edit to the news article, you can say that I do want to see this reflected in my app. We will take that data, write it to the cache, and then when your app reads that cache, you'll actually see those edits. Then when you come online, those mutations are saved and basically queued up until you're online. Then when you're online, we replay these mutations, these edits of the article, and then the service will be updated and your local copy will basically be reflecting that already. All right, so at this point, we went over AWS AppSync. Let's see how we can provision these with AWS Amplify CLI. What is AWS Amplify CLI? We'll be using it to provision backend resources, and later on we'll see that we can configure it as code. What we'll be doing today is modeling the data with GraphQL. This will get transpiled into AWS CloudFormation and then deployed to your backend. It'll be creating the AWS AppSync APIs, creating the DynamoDB tables behind that as well. And overall, there's minimal GraphQL knowledge required. So to get started, we say amplify init. So inside of your simple Android app, you'll see that a Amplify folder is added. This is where we'll be keeping a lot of metadata and state for your project. Then we'll look at how to actually provision these resources once your project is initialized. We'll call Amplify add auth. So this will be provisioning both your Cognito user pools and Cognito identity pools. This will show up as a AWS configuration JSON file in your resources folder. Basically, the JSON that will be added at this point will include your pool ID. It will include your client ID, client secrets. The user pool will be used to keep track of your users. The identity pool will be the one that has the policies attached to it to allow your users access to your AWS resources. The next is analytics. If you say amplify add analytics, the same JSON file will be updated with your analytics app ID and your targeting region. And then the same pattern, amplify add API. The AppSync URL endpoint will be added. This is a custom endpoint for you and only you. This will be hosting all of your endpoint APIs and also includes your auth mode, in our case API key, since we want to keep it simple, and it'll include the API key itself. All of this JSON will be read by the SDK automatically. So this is just to show you what's happening, but the SDK will be reading that automatically, and you don't have to deal with this overall. And let's switch over to, oh Lord. Okay. Oh, this went to sleep. Switch over. Okay. So when you call Amplify add API, one of the prompts will ask you whether you have an annotated schema, and this is where basically you'll be configuring. You have configuration as code. With our news, social news app, we basically have 3 objects that we want to look at. The first is a news object. We'll annotate that with a @model, saying that we want all the CRUD operations: create, read, update, delete. This will be translated into queries, which are the read operation, the mutations for update, create, and delete, and then subscriptions for when new ones are being created whenever they're updated or even when they deleted. You'll see on line 2, basically, there is the ID. This tells the service that the ID field will be the one that's uniquely identifying the news article, basically like a primary key. And then you'll see the fields that you'll be configuring, such as the title, synopsis, content, image. You'll see that most of these are strings, but one thing right after the string is the bang. You can actually specify whether or not these fields can be nullable. So if you send a title that is null, the service will reject it, and then that translates into your client has to do less null checking. So you can rely on certain fields being there without having to worry about a null pointer exception. Another is that the image doesn't have this bang, so sometimes news articles don't have images. This special type is an S3 object. This gives you what we would call complex objects. This equates to images, videos, binary data, things that you probably wouldn't store in a table. That is shown here as a type S3 object. This basically includes the bucket key region and the local URI that you might be uploading from, and then MIME type if you want to specify more details about it. But basically you have the news article type. This has one more field, which is the comments. You can see that it's a list of the type comment, and you can see down here we basically defined it as the same unique. It has an ID, it has the commenter attached to it, and the message that they've actually written. They're also connected by the @connection. So both of these have @connection. The one up here basically says that the news article can have many comments, while the comment will be attached to only one news article. And then you'll have this name here to tie these two together, representing the relationship between these. The CLI will take basically these 3 simple models, transform it into CloudFormation. The CloudFormation you don't have to worry about too much, but it will be the one that's provisioning both the AWS AppSync APIs for you, as well as the backend DynamoDB tables that will be actually storing this, acting as the data source. It goes on and generates roughly 1,500 lines, so it does a lot of the heavy lifting for you as long as you know what shape your data is actually in. Once that's created and deployed, the CLI will do some cookie cutter code for you. It'll generate the queries. The queries, again, are the read operations. So you can pass in the ID 123 and get back all the information that you request here. So for instance, if you say get news, you might want all these fields. Then you look at list news. Okay, we're asking for a lot of information here, so we can take away maybe all the way up to this point and say we only want the ID, title, and synopsis, and potentially if there's more than 50 or something of that nature, you can have a next token so that there's pagination involved. All right, that's okay. So that's what the Amplify Add API will be doing. It'll be creating all of these things and creating the graphical queries, mutations, subscriptions that you can use in your code. So let's start with something easy. So that means all of the cloud backend has been provisioned. So let's look at how to interface with that with the SDKs on your app. We'll take a look at Amazon Cognito and how to sign in. So why is sign-in tough? Sign-in is tough because if you were to do it by yourself, you'd have to manage the entire directory of users, their passwords, and overall the security protocols surrounding those. With Amazon Cognito, you'll be able to easily identify your users, provide them elevated permissions, in our case, the ability to comment on the articles, and best of all, you'll be able to personalize their experience. Once you know who they are, you can keep track of the articles that they're looking at, say for instance, pineapples or their favorite band, and you can send them push notifications about those topics. How do we do that? So the code here starts with AWS Mobile Client, which is our solution for authentication. You will call AWS Mobile Client get instance, so this is a singleton. You'll say show sign in, and this will bring up our drop-in UI. This shows users a sign-in page where they can fill in their username, password, and supports multiple flows like forgot password, create account, MFA. So if there's security involved, you can ask the user for a SMS code or email code, and they can sign in. And if they choose to configure it, you can also have the sign-in UI support social sign-in like Facebook or Google, which is relatively easier for a lot of our users. The next is how do we interact with AWS SAP Inc. So it's generated a bunch of GraphQL queries, mutations, and subscriptions, but that doesn't really work well with our Java or Kotlin code. So what the SDK does is it'll actually take these actions and create the Java interfaces for them, and by extension, Kotlin will be able to use that as well. It will take in the selection sets, and then internally it'll have an offline cache and support for complex objects. So whenever you do a mutation to create a news article, it'll detect that you have this S3 object, take that local URI, upload it to S3, and then that information will be there for you when you want to retrieve it from a query. So how does that look? This is the query code. You'll start here where it's a builder pattern. You can pass in the news ID that you want, for example, 123. You'll get back this query object. You'll pass it over to the client. You'll say client.query. Then on top of that, you can say that you want network only. Since we're not relying on the cache in this example, we'll use network only. Otherwise, you can say cache and network, and the response from the cache will be guaranteed to be first. So you can show something from the cache, and then network will come later, and then you can update that UI as well. So for our example, network only, we're treating it as such. And then since it is network, we don't want to run it on the main thread, so this will enqueue it and then run it on a background thread. When the response comes in, you can take that response and save it off into the database layer. Otherwise, you can deal with the failure, on failure. And similarly, the subscription code, which will be pushing you the deltas so that you can keep your information up to date, also follows the builder pattern. In this case, you can specify that you want to listen to create comments. So new comments that are coming in, you can see them stream into your news article. In this case, you take that subscription object, you call subscribe, and it returns you a subscription watcher. On top of that, you want to call one extra method called execute. So this tells the subscription to start listening, and it tells the AppSync servers to start pushing whenever the interesting events start coming through. You'll see that on response is the same as before, but one thing different is that you'll be getting multiple responses. As new comments are being created, this will be fired multiple times. And then if there's any failures, you'll be notified on failure. And then once you want to stop listening, for example, the user has navigated away from the view, you can say cancel, and the onComplete will be called. All right. So that was AWS AppSync. Let's see how to interact with Amazon Pinpoint. With analytics, you learn about your users, so you can push them information that you think is relevant to them, further engaging them. The analytics code is relatively straightforward. We're basically here getting the analytics client and calling record event. Then the event that we're recording can be generated with create event. In our case, we're saying that it's a UI event, and they've clicked on a certain use ID, and we're going to pass that in and create that. Once all of this information is collected, you can run this simple command, Amplify Analytics Console. And this will show you the analytics from any app runs. So I've just run Amplify Analytics Console, and it'll bring you to the pinpoint console, and we can navigate to events. So I played with it a little bit. You can start filtering your events. We only have UI events right now. So we say we want to look at UI events, look at what people have been clicking so far, and you can start seeing all the other events that are coming through. I've attached some for sign in, some for sign out. You can see how many clicks I've been doing lately on sign out. You can also see how many clicks the news articles are getting. For example, you can see trends, see if any news articles are gaining popularity or anything of that nature. And you can access that through the console here. If you want to do more analytics on these events, you can always export these and then run any queries that you would like to run on them. So, let's see. So at this point, we've done all of the code to talk to the cloud. Let's look at how to actually keep that in our local architecture, our application architecture. What we're trying to achieve is we want to store the data and keep the data up to date, because stale data is not so great. But on top of that, we want to prevent any memory leaks. While we're updating UI, we're holding references to the UI, and we'll be looking at a clever way to use live data to prevent any memory leaks, and also live data to push updates to the UI. So again, this local architecture diagram, we're going to be starting on the bottom left with the model and room. Let's see how to actually set that up. So these are all Android architecture components. If you don't, you can read more about them later on if you don't fully understand. But just to introduce you, the room database, this is one way that you could set it up. We're using the @database annotation. We're saying that we have a news data object that we'll be using, and the news DAO that is going to come out of it. That news DAO is defined here. You can use the query syntax that you're familiar with, select star from news where ID equals the news article that you're looking for, or maybe if you want to look for the newest articles, you can use order by. These are all SQL syntaxes that are supported. So you'll annotate these, and then you can add any methods that you want, whether to load the articles, whether to list the articles. And when you save it, we're using replace, because we feel like the information that we have will be the latest. The live data that's being returned here is a observable data holder class. So unlike regular observers, live data is lifecycle aware. So once the activity is dismissed, it'll say, okay, there's nobody else looking at me, so I can stop updating my code that I have references to, and it'll respect that lifecycle as well as any activities that we're using. So from the DAO, we're going to go over to the entity itself. This is basically just a data object. So you see the same fields that we configured earlier in our model with the ID, title, synopsis, content, publish date. So that's relatively straightforward. And we're using ID as our primary key, which we annotate right at the top. So the repository is what was deciding where to get the data from, whether from the cache of room or to go online and retrieve information. So the pattern you see here for get news is that we kick off that refresh news. that async call to the web to say we want the latest and greatest of that news article. And then right afterwards, we say go to the database, load this news article if you have it. This is what we have in our database. Show it to the user first so that they know that something's loading. And then afterwards, when this async operation completes, then it will go and update the user through that live data mechanism. So here we see the refresh logic. This is the same query syntax that we saw earlier, except this is for list. So we do another list with the builder pattern, pass it to the client, and then when the response comes back, we actually save that information to the news DAO. That news DAO go right to the database. The database layer, which originally returned the live data, will now notify that same live data with new information, so you don't have to go back and write custom logic for that. The view model will be basically transitioning that live data upwards. And then finally, you see in the view that with the view model, you say get news list, and then you call observe. This observe is a method of the live data, so you're observing the live data. The first time it comes through, it's taking that cached information and setting that information in the adapter. The second time it comes through, it's coming from the network, and you don't have to do anything different. It'll just update the UI with the fresher data overall. I totally forgot we had highlighting. So those are the two I was talking about. The view model itself was basically from here. Then you call get news list for your specific method, and then you'll be observing for that. Same UI code will be used for your cache information as well as your network information. So what did we learn today? How to make something responsive. How we do that through caching. We can cache for speed, and we can cache for offline usage as well. We're looking for efficient network usage. With GraphQL, you can use basically selection sets to say I want just the title, or I want the title and the content and the comments overall. And this will reduce the need for users to waste their bandwidth on certain information. And the data-driven UI updates allow you to use the same code to update your UI without having to know where it's coming from, whether the cache or the network. And the major messages are that we're using serverless for scale. All these services that we're using will grow with you, whether you have 10 users, 100 users, or 1 million users. All these services will scale with you. We want to respect the users by using as little bandwidth as possible until it gets to the point that they need that information. And then overall analytics on what the user is using the app for, how are they interacting with things, and what are they interested with. Okay, so thank you. We can do a small demo of the app running since we have some time. Let's see. Oop. Just missed itself. Okay, so you can see we're not signed in right now. We can go to this. There's a short loading on the screen where it hadn't loaded the actual contents of the article. Since in this view we don't need that information, it will do a short load and then it will cache that information for you. We can try to add comments here. Then it will prompt you that you need to be signed in. So we can go back and do a sign in. At this point, we do the sign in. We're seeing the drop-in UI. So for users who are already signed up, they can go ahead and put in their username and password, and then click sign in. If they need to create an account, they can do so with their username, password, email, and go back and go ahead and sign up. If they've forgotten their password, they can put in their username in this field and hit forgot password and be emailed a code on how to reset their information. And if you configure it on the bottom half of the screen, on this white space right here, if you configure it, the Facebook and Google buttons will show up to federate those users who want to use their Facebook or Google account instead of creating a new account overall. So we can go ahead and sign in. right? So now the top right corner, the sign in has now become sign out because we're in a signed in state. We'll go here and we'll say, you know, what is up with grapes? Something of that nature. This will be sent to AppSync, and then I promise the information that's coming back, you'll see that it's actually going through the subscriptions and coming back on the top, what is up with grapes. I believe I've done this before, but without the question mark, as you see here, and all this information is up to date, we can say, okay, let's see if that works offline. We come back, we still are able to load this page, we still are able to load the full information. Okay, man, this is all saved in memory, so we can try killing the app, opening it up again. We still see the news articles, we still see the information in the comments that were added, and we still don't know what is up with grapes. So, thank you. That's it for me.